Aloha, Richard Halverson here. This is ICS211, and today I'm going to go over insertion sort. So let me share my screen. All right, so insertion sort is similar to selection sort in that we've got an outer loop and an inner loop, and the index of the outer loop separates the sorted section from the unsorted section. It's the same. To the left of the index is sorted and to the right of the index is unsorted. And as the outer loop increments through, it adds elements to the sorted side, but it's a little bit different than selection sort. So let's go through this. We start out. We have we start out with I equaling 1, which means I equals this index here, and then we set J. We set I equal to 1, and then we set J equal to I, and then we are gonna insert. Okay, so we start out where 32. Just 32 is considered sorted. Then we're going to insert 6. And so 6 is going to be shifted to the left until it's in its proper place. And then we're going to do 15. And then we're going to do 3. And then we're going to do 20. Each time, when we get to 3, everything to the left of 3 will have been sorted, and we're inserting 3 into its proper place. Same with 20. So let's see. So now both I and J are at 6, and we're going to insert 6 into its proper place. So we check to see if the numbers J is less than or equal to the numbers J minus 1. And while it is, 6 is shifted up. So now you see 6 took 32's spot. And now we're going to go to 15. And everything to the left of 15 is sorted. And now we're going to insert 15 into its proper place. It does some comparisons here, and 15 shifts to where 32 is. This is the exchanging. And then it tries to see if 15 is, it still needs to be shifted left once. It does not, because 6 is less than 15. And so it's done. And then next it does, it goes to 3, and everything to the left of 3 is sorted. And then it inserts 3 into its proper place. We see that 3 is going to be shifted all the way down to where 6 is. 15 will be shifted up 1, and 6 will be shifted up 1. Can we turn this double speed now? Yes, we can. And then after this is done, 3 is shifted into its proper place. And then next we do the last one, where 20 is now shifted into its proper place. It just ends up trading places with 32. And then we're done. All right. So let's go to presentation. Oh, we are in presentation view, right? Here's presentation view. Okay. The insertion sort algorithm is here. Here, this is similar to what we just saw in the selection sort. We read in, we define a set of unsorted integers. We display them out. We sort them, and then we print out the sorted list. The sort algorithm, it's got I and J again, a temporary for temporary variable. We sort from the outer loop goes from not index 0 but index 1 up to the size of the array, up to the last element of the array, and then the while loop loops down. J goes down. J starts at I, and then it increments down, shifting the index in the ith position, shifting that down until it's in its proper place. And it swaps elements. It swaps adjacent elements along the way. So that's how that works. Here we can see that a nearly sorted array list does very few exchanges. 1, 2, 3, 4. If we and so if you already have a nearly sorted list and you just want to maintain, you want to sort it, or if you have a sorted list and you want to add elements to it, insertion sort is a very inexpensive sort, because it does well when the array list is nearly already sorted. It is nearly sorted. All right, so here's a challenge activity. Let's take a look at this. Okay, I'll start it up. I'm gonna tell you what I'll do with number 3. And okay, given a list, when the index is equal to 5, the outer loop is equal to 5, how many swaps will be performed in the inner loop? Okay, so I is equal to 5, 0, 1, 2, 3, 4, 5. Okay, so I is equal to 5. How many swaps will be performed in the inner loop? Okay, so it looks like 34 just needs to be swapped into its position, which is just to the left of 35. So I think only one swap is going to take place in the inner loop. 35 and 34 will swap, but then 34 will test with 32, and a swap will not be needed. And once 34 is swapped into its proper place, it doesn't have to go any further, because it's already in its sorted position. So I think it's only going to happen once. Yes. All right, so you can do the rest of them. All right, let's do this insertion sort lab. And okay, so in this lab, it's similar to the previous one, where we're going to read in an array, except for this time, the first thing we read is the number of elements in the array. Remember, in the previous lab, we had a sentinel where -1 indicated that there were no more elements coming. This is the other way to do it, where we tell your program how many elements are coming, and then we read those elements in. In this case, it's gonna output first the unsorted array, and then after each iteration of the outer loop, it's going to display that out. So the first time, as you see, it's gonna swap 2 into its proper place, and this is the outer loop. Then it's going to swap 1 into its proper place, and then this is the loop. This is the output after that outer loop iteration. Then it's going to do 5. 5's already in its place. Then it's going to do 9. 9's already in its place, and then it's going to do 8, and 8 gets swapped into its place. And so we see that there were 4 comparisons, and 7 comparisons, and actually 4 swaps. And so this is the program, and we don't have to do much. We only have to count. We have to put in where we're going to count the comparisons, and where we're going to count up the swaps. And so we're supposed to complete step 4 is output the number of comparisons. 1 and 2 are already done in the code. Perform the insertion sort array, that's already done also. And so we just have to put in where we count, and then the actual output. Okay, so let's see, what am I loading in the default template? Okay, so default template here. Okay, so here we read the numbers. Let's go down to the main program. Here it is. We start out with initializing an integer array. We print out the numbers, print a return, do the insertion sort, and then print out a print line. Oh, because the insertion sort is going to display out the output after each iteration of the outer loop, after each pass of the outer loop. And then at the end, we print out the number of comparisons and the number of swaps. Okay, so first of all, let's go into the insertion sort. Here's the insertion sort, and this is a finished insertion sort, it looks like. Goes from numbers, this is the outer loop, and then this is the inner loop. And okay, so we're counting swaps. Oh, first of all, let's initialize these variables. Now, I think we have to declare them as static because they're outside everything. Integer comparisons, and we're gonna do static integer swaps. And we're gonna count swaps. Let's see. This is where we print the numbers. This is okay. So, okay, this is here's where we swap. So for sure we need to increment swaps here. And okay, so we need to count comparisons. So this is the comparison that we need to count, because that's gonna tell us whether or not we need to swap. If that is true, if it's true that the number to the left, this is the number to the left of this number, this is j minus 1. If this number is less than this, if this number at j minus 1 is greater than the number j, the number at index j, then they have to be exchanged, okay? If this is smaller than this, then they're out of order. And this one should be smaller than this. And so then they're exchanged. So with this while loop, if we get to here, then we've either gotten here because of this, or we got or because yeah, we've this comparison is true. All right, tell you what, it's better if we separate out. It's better because we don't want to count this as a comparison. When this while loop terminates, it's going to either terminate because this fails, or it's going to terminate because this fails. In other words, j has hit 0. So what I was going to do was I was just going to count up comparisons, but then if we end up being down here and j is equal to 0, then I was going to subtract one comparison to it. Turns out that does work. That's what I did earlier, but it's actually better if we separate out the comparison. So let's make this be the while loop, and then inside here we're going to do if numbers is less than j minus 1, then we want to, okay, then we can count the comparisons. Comparisons are counted right above right here. There's a comparison coming. If this is true, then we need to swap. We need to swap, count the swaps. Get rid of this line. And if we have to swap the numbers, we swap them. If we don't have to swap the numbers, then we can exit the loop. Okay, if we don't have to swap the numbers, then the number that we were shifting down, which is this one, that means that this fails. That means both of these are in their proper position. That means we're done. We can exit the outer loop. So let's just do else. And I think the way to exit a while loop in in Python is with a break, the word break. So else break. I think that'll work. So this is the if case. If the numbers are out of place, then we swap them. We count up the swaps, then we decrement J, and we come back around here. And then if J gets decremented all the way down to 0, then we're done. Then everything is in its place. Then it turns out that we just swapped in the smallest element of the array. All right, so this should sort. Okay, let's print out the array, and that is with the print nums numbers, and then I guess let's maybe do a system. So I'm going to see what this looks like now. The last one is 1, 2, 3, 5, 8, 9. 1, 2, 3, 5, 8, 9. Okay. All right. So what's missing is, oh, I'm supposed to print out the swaps. Silliness. All right, let's print. That's what I'm supposed to print out. I'm not supposed to print this out. I'm supposed to print out the swaps. So let's change this to. Sorry, I didn't. This is going to happen. The last iteration of inside here. I'm going to leave the print line. This should go someplace else. Okay, this should go right here. Okay, so I'm going to leave this for you to put there. I'm talking about this part here. But down here, we actually have to print out the number of comparisons and swaps. So let's do that. Let's see, print system out, print line, comparisons, and then let's put the swaps in there, comparisons. That should work. And then system out, print line, swaps. Let's see what this looks like now. Okay, comparison 7, swaps 4. I'm gonna put this is an error. What I'm actually gonna put it at the outside of the for loop. So this is the finishing up of the for loop. I'm gonna print print nums numbers. Can I do that here? What happens? What does this do? Okay, that looks like that works. Okay, now to test whether I got my comparisons and swaps correct, I'm going to submit it. Okay, I'm going to submit it just because I want to see if I got the swaps and the comparisons correct through all with all the tests. I'm not going to get this part correct because I'm not printing out the output after each loop. I'm printing the output after the for loop is done. But I got these right. I got these right. And I got these right. And I got these right. I got these right. So I got the comparisons and swaps right. What I missed out on is printing. This is in the wrong place. and I'll leave that to you to fix. So I've taken you through 18.4 description of insertion sort and this 18.5 lab. So I hope this helps. Thanks for watching.